All right, this is the projectile simulation 2. In this lab activity, we'll explore projectiles being thrown in the upward direction. So click on the link posted below. So this is going to be on physics classroom. So this is the projectile simulation. So set the simulation up like the photo to the right. So the speed will be at 10 meters per second. So you set this to 10. You notice that it goes in 1 meter per second. We're just going to go by 10. So we're going to go 10. Then it says the angle will be at 90 degrees. So that will set it on a path going in the direct upward motion, right? 90 degrees. There we go. Then the height will be at 0. Okay, then we want to click these 3 buttons like this. So the first question, it just says start the initial velocity at 10 meters per second. So that's what we're going to do. Record the time to peak and the y displacement to the peak. So the time is going to be located up here at the top. The y displacement is down here. So we want the time to the peak to where the y displacement is at the highest point, right? So we want wherever it reaches, and then it's going to eventually come back down. So increase. So let's see here. So there will be arrows up at the top that we're going to have to pause it, and then we're going to have to fast forward it or rewind it 1 frame at a time to find where y displacement is the most. Let's see the peak. Okay, there we go. Increase the initial velocity by 10 meters per second, and then repeat. Place the results there's a Google Sheets attached to the assignment, and copy the chart in the space provided. So let's just go ahead and look what happens at 10 meters per second. So we can shoot, this is going to go up and down. So it's kind of hard to see because it's not a very large initial velocity, but it's basically just launching this projectile up and down. You can see it took 2.041, but that's all the way up and down. We want it just to the peak. So what I'm going to do is I'm going to hit start and I'm going to pause it. Okay, so now I need to figure out where this y displacement is the most. So we're at 5.4 meters. If I fast forward, okay, it's going back down. So I want to find that peak. So 5.4, 5.11, okay. So 5.7, and then there we go. So 5.11, that is going, or 5.11 meters. That is the peak. That's that displacement. And then we can see the time that it took there is 1.04 seconds. So let's go ahead, reset, and then it says increase it by 10 meters per second. So now we're up to 20 meters per second. Then I can start, and I'm going to pause it. So right here, it's probably about at the peak here, 20.41. Let's see here. Let's go 41. Okay, so it's going down in that moment. All right. Okay, so it's going down. So we actually did hit it right at the peak. So this would be the y displacement for this one. And notice that it takes 2.07 seconds to get to the peak. Because on one side, well, it's going back down there. It's going back down on the other side. So that's the highest y displacement that we have, right? Okay, so then we can reset it, go all the way up to 30, and we're just going to keep redoing this. There we go. Oh, nope, that's at 29. That'll mess up our graphs. All right, so we'll hit start. We'll wait till it just about gets to the peak, and then we'll pause it. So now it's at 45.8. Let's see here, 45.91. Okay, 45 point, let's see here, 9191. Okay, so this one's kind of tricky because it's sort of it's at 2 different times that it's 45.91. I'm going to go with the most one and say 3.12 seconds. That might just throw off the acceleration a little bit, but you can see here at 2 points it's at that peak. So I mean that's like basically a tenth of a second there. So I would just go with the most point, or you could just split the difference, right? Maybe say around 3.6, but I'll just go with 3.12 seconds. All right, so now let's reset it, and we'll go all the way up to 40 meters per second. Notice what's happening to the velocity vector. There we go, 40 meters per second. All right, I'm going to start, and just when it gets to about to the peak, there we go, I'm going to pause it. Okay. So on that side, okay, it's going back down if I go that way. 5, 4, 6, 3, 6, 2. Okay, so there it is, right? 81.63 meters. That is at 4.13 seconds. All right, let's go ahead, set, go all the way up to 50 meters per second. Oh, didn't mean to do that. 50. There we go. Hit start. All the way up. There we go. There we go. Oh, pause it right there. Let's see, 5.5. Let's see here. So 55, 54. Okay, so right there. So it's 127.55 meters. It took 5.15 seconds to get to that peak. All right, let's reset it. Go all the way up to 60. All right, so now So the most you can see here, notice what's happening to those vectors. Let's see here all the way to the peak. There we go. All right, so I went above the peak, so 4, 1, 5, 9, 6, 7, 6, 6. Okay, so right there, 183.67 meters, and it took 6.16 seconds to get to the peak. So if you enter that into the spreadsheet, it'll give you a graph that shows, okay, with the initial velocity, how does that affect the time it takes to get to the peak? And how does that also affect the displacement, how high that object went? So if you look at the graph above, okay, so that'll get you the graphs, and you can answer those two questions. I'll give you a hint. These graphs are graphing one of the kinematic equations, right? So that's kind of the hint on that one. That's what we're graphing. All right. So once you do the 60 meters per second, you enter into the graph. It'll give you the it'll graph position, velocity, and acceleration versus time. It'll give you those three graphs. And then if you look at those graphs that show the four conditions of motion, when graphing an object's position versus time, what does the slope of the line represent? Is the slope linear or not? What does this mean? Use the data to justify your answer. Then it says, look at the graphs that show the four conditions of motion for projectile being thrown upward. I'm graphing the object's velocity versus time. What does the slope of the line represent? Is the slope linear or not? What does this mean? Use the data to justify your answer. And then now we're going to look at just the velocity versus time graph for projectile being thrown upward. What affects the sign? So positive, zero, or negative of the velocity. Is the velocity ever positive? Is the velocity ever zero? Is the velocity ever negative? If so, when? So explain your answer. So the last question says, when a projectile being thrown upward, does the acceleration change? Why or why not? And I give you a little hint there. What is causing the acceleration? So once again, this is the projectile simulation 2 for projectiles being thrown in the upward motion.